Hi, my name is Chris Trujillo, and today I'll be presenting introducing our presentation. I'm the structural engineer, Daniel Pena is the transportation, Braxton Bowen is the water resources, Michael Ragland is the geotech, Brittany Kaysen is the environmental. We were tasked with designing a office building for Tarleton State University back in 2020. The structural component, it is to design the superstructure and all components such as the columns, beams, and the slabs.
The geotechnical objective is to design a foundation to safely support the new Tarleton State University engineering office building.
Responsibility will to design a parking lot for the proposed new office suite building.
The water resources objective for this project is to effectively manage stormwater at the proposed site. For this proposed site, the runoff occurring from the office suite itself and the adjacent parking lot will need to be controlled.
The objective, I had to design a treatment system to remove soil that was contaminated with lead.
The project deliverables, like I said, are designing that and other certain requirements that the client has asked for.
Deliverables for the geotechnical section are stated in this slide.
Some of the project deliverables requested by the client are as follows here. Design of the pavement, provide the inspection and testing guidelines, some detailed drawings, and also a cost estimate for the parking lot.
My deliverables were a treatment system as well as a cost estimation for the system.
The stakeholders for this project are the faculty, the students, and the future students because they will all be affected by the construction of this project. At the current stage of the project, we only have two main design criteria to take into account: the ASC 7-10 for the estimation of the minimum design loads, and for the preliminary beam and column and everything design, we used the architectural drawings to meet the desired clearances.
The design criteria for the foundation designs are stated in the following slides.
The design criteria is to take into consideration the ACI 330R, which is a guide for the design and construction of concrete parking lots, and also the geotechnical reports.
There's 4 major design requirements that need to be considered. Peak flow from the new site must be less than or equal to the peak flow of the old site. A new site condition must be as similar as possible to the old site. Stormwater system must be able to treat the first inch of stormwater runoff. The stormwater system must be able to handle the runoff volume for the system that it was designed for.
My criteria I had to follow was making sure the system followed the EPA regulations, which was making sure the lead is under 400 milligrams per liter.
Reinforced concrete versus steel. We picked reinforced concrete because of many reasons, basically mainly because of firm experience.
Design alternatives for the shallow foundation design are different types of individual footings. They are pictured here, with square footing being the base design, and the process for shallow foundation design is pictured here.
The design alternatives looked at were concrete, asphalt, and gravel. Here's the process train for a concrete parking lot. The decision matrix, the baseline design was concrete and it scored the highest.
The load estimation was calculated through the AC 7-10 and a page by Matthew Ziff, or pages that had weights of different materials. And we used the basic loading combinations in the AC 7-10. And here are the story 2 and 3 load estimations, which the final result can be seen here. The roof load estimations and the roof load estimations with the basic combinations. We used robot structural analysis for the analysis of the structure, preliminary analysis, and here are the results that was given to the foundations so that he could design the foundation.
For ultimate bearing capacity, Terzaghi's method was used. These slides explain the procedure, and allowable bearing capacity was calculated to be 6.65 kips per square foot. For elastic settlement, the Schmerkmann's method was used, and the final calculation for elastic settlement was calculated to be about 0.2 inches. For consolidation settlement of the shallow foundation, it was determined to be about 3.72 inches, making the total settlement about 3.93 inches. Pile load capacity was determined using rock quality design of an end-bearing pile, making the pile load capacity of 293.05 kips per pile.
The design details. The current progress is that the design of the pavement thickness, joints, and exterior reinforcements has been completed, and the rest remains yet to be completed. The preliminary pavement thickness is a 6-inch granular aggregate subbase with a 5-inch concrete base on top. The preliminary joint design will be contraction joints with the following characteristics, and they will be square panels spaced at 12 feet. The steel reinforcement design will be dowels and tie bars with the following characteristics. These were based upon the slab depth of 5 inches and the tie bar spacing of 12 feet. The tie bars will be used only on the first longitudinal joint of the parking lot, and the dowels will be placed on all other transverse joints.
This is the baseline design. This is a gray stormwater infrastructure. The runoff will follow the flow path, which is the blue arrow, to the closest inlet. The water will then enter the stormwater system pipes, which is the red arrow. The water will then flow to the closest stormwater main, which is the yellow and orange arrows. This is the alternate design. It is a green infrastructure stormwater system. The runoff occurring from the office will enter a flow-through planter box and then flow to the closest inlet, where water will be directed to the Bower retention pond. The water will there be stored and treated until released into the West Tarleton stormwater main, which is the yellow arrow.
My designs, I looked into vitrification, electrokinetics, and solidification, stabilization. I also looked into sunflowers, which add a aesthetic value, as well as they can remove lead through their roots. Vitrification is a thermal treatment. Electrokinetics electrically charges the soil bonded molecules, and solidification converts the soil to its least soluble and to prevent migration. Here's just my design matrix showing that electrokinetics is the best option. And this is just some more information, more just deeper.
And our Gantt chart to keep us on track. And we had many considerations taken into account for this project.
Considerations include low carbon emission concrete for the environmental section and supplementary cementitious materials to reduce the cost.
And these are just some considerations I have to take in for my system.
And here are references. Thank you. Any questions?